Hello, welcome to Trouble Television once again. Today we are going to look into how we actually can render something on the isometric tile map we built last time. If you didn't check out the last video, please do so. It will explain a little bit how we actually built the map and give you maybe a better understanding of how the process works. All right, have fun. Hello. Today we are going to look into how we actually can put something on a tile map we built in the last part. So last time we looked into how we actually can set up a tile map, how we draw the tiles, how we calculate if there is some mouse interaction with a tile. And today we are going to look into how to put actually some rendered objects on it. To recap a little bit, I restructured our code to have it a little bit more accessible and maintainable. So basically I extracted the tile map code into its own module, same for the tile function or constructor we use in the tile map. And I also created a tile map setup function that basically does the same thing we had before, to actually build up our collection of tiles we use then to draw or to interact with. So before we actually get into Blender to render something we can put on the map, maybe introduce a new function in Love. So Love itself has like a pretty nice lifecycle system where you have several functions that are called on lifecycle of the game itself. For example, draw is called every time a frame draw is triggered. Mouse move is always like checked or executed when there is like a mouse movement. And there's also a function that is called love load, which is to be thought of as like the init point of a game. And love load is basically constructed in a way that it runs only once when the application starts. And it is thought of as an entry point for expensive operations like loading assets or generating stuff or calculating stuff. And since we are going to work with assets today, I am going to introduce it right now. And I'm also going to move the tile map setup code in here, so we have like a better game structure after all. All right. So far so good. Let's get into Blender and actually render something. Okay, let's render something that we actually can put on our map. Maybe you recall from the last part in the scaling chapter that we actually talked about already what kind of view angles we changed. And this information is now actually quite usable to render something that we can put on the map. So first, maybe reset the rotation of the camera, then rotate it on the x-axis by 90 degrees, and then apply the angles we said we have for our tile map. So first what we need, change for the x-axis again of 30 degrees downward, and then we need a rotation for the z-axis of 45 degrees. Then we actually have like already the correct view angles for our isometric map. Then we need to change the render engine to cycles. We need to change the perspective or type of the camera from perspective to orthographic. And then we also want to activate the limits in the viewport display. By doing all that, we actually see now that when we go into the camera view, we see something that might be able to be put on the map and still looking coherent. Let's change the visibility to wireframe and then move the camera around a little bit so the cross of the limit actually aligns with the root of the coordinate system of Blender. Some little advice from me, I would set the resolutions for X and Y to the same value. Okay, let's change back to solid mode. Let's move this cube one up and then add a plane. This plane is really not necessary for us to be rendered. We just need it as a shadow catcher. So set it as shadow catcher, visibility, shadow catcher, and then add some lighting so we actually see something. Maybe move the light down here, change the type to area, reset the rotation, and then rotate it in the x-axis so it actually lights our cube, and then give this a little render. Okay, so the render is finished. Actually, there are two things I don't like about it. First, the shadow is cut off here, so we need to change the angle of the lighting and the positioning, as well as we don't have a transparent background yet, and we would render actually like this image on the map, so we would have like a dark gray background. So let's change those two things. First, move the light a little closer, first rotate it a little more, and then move it up, and then go to render properties, and in the section film you just activate the transparent mode. And if you render now, okay, so the render is finished, and as you can see now, we don't have any cutoff shadow, and we have a transparent background. So let's save this image and go back into our code. Okay, so back in the code, you can see here that's the rendered cube image. I rendered it in full resolution just because, yeah, maybe we want to have some zooming features in the future. And it would be a shame if we zoom in and like the cube looks all chunked up. So I rendered in full resolution. I'm going to scale it on the map itself. And one consideration as well, when you rendered the image, save it as like an RGBA type file, like PNG with RGBA, because you need an alpha channel to actually save the transparency. If you don't do that, it will, I think, default to black or white, one of them. And then you have like a little bit of an issue when you try to put it on the map, because you actually just want the object with its shadow and not like some background. Okay, so since we have our image now, let's continue with the code. We need some kind of bridge code because we want to have access to the asset of the cube in main to actually set it in load, but we also need access to it in the tile code, because here we actually want to render the cube. So I created a new file. I called it assets.lua. What I'm going to do in here now is I create a variable called assets, which is a table and has a property called catalog, which is also a table, and I'm going to return assets. So what this does basically is it allows us to require the assets.lua file in main and in tile, but we get the same table as like a require result. That's why we are actually going to add two more functions to assets. First, we want to add the add function with name and image. And here we are just going to append the image to the catalog with the name. This function we are going to call in main. And then we want to have a second function, which is called get, which also receives the name argument. And in here, we're actually just going to return the catalog entry with name. All right, so in main.lua, we go into our love the load function. First, maybe also require the assets in here to actually have them loaded. And then we are going to add a new asset with name cube. And in here, we are going to say love graphics new image and the path to the image, because like cubes on the same layer, we just put cube.png. And in tile, we are going to require assets as well. And then we are going to render them. Okay. So maybe a quick consideration when looking on the map. Okay, so here you can see our map, and what we are actually want to do is to render the cube on the tile when it is hovered. To do that, we actually need some calculation to get the correct coordinates. The first is that we want to figure out where the image X is going to start, because images work like that. You pick an X and a Y, and then you say basically what is the scaling factor, and then Love will render it starting from the X and Y position to the like in width and height. So you need to calculate basically the starting point to actually place it on the tile. What we are going to do is we say the X position is left of the center half width, and then we assume now that actually in isometric relations the height should be the same, because like each tile is technically like one side of a cube. So what we are going to do is now we say the full height of one tile is like our z-axis kind of. So we are going to say move the X to the left and the Y to the top, and then render the image with like a proper scaling on the tile. So actually, to actually do that, we first need to calculate the scale. We want the image to be appropriate to the map. So let's create a variable called scale, and scale is in the easiest sense width divided by the actual image size, and this is 1920 in our case. So now we have the scale, and next we want to do is actually call love graphics draw. Love graphics draw accepts multiple arguments. First, it accepts a drawable, in our case an image. So let's get the image, get cube. The next argument is the X parameter. What we are going to do, actually let me put all the parameters there and explain them. So first we have like the X, second is Y, rotation is in our case 0 because we don't want to rotate the image, and scale X and scale Y in our case is actually scale because we are working with a quadratic image. So X in our case is this, or sorry, self X minus width divided by 2, and our Y is self Y minus height. So let's see if we actually put it on the right spot. So as you can see, we actually put like the cube on hover on the tile in the correct position, but there's some caveat that I actually didn't explain before. So as you can see, the image is rendered correctly, but there is like an edge that is now intruding into like the image itself, or it is drawn above actually, like on top of the image. And the reason for that is that actually our render order is wrong, because right now we are rendering like the rows like that. We say first row, second row, third row, but what we would need to do is technically render them differently, that the next tile isn't overlaying the previous tile basically, or the tile in front of it. To fix this issue, actually, it is quite trivial. We are just going to tile map. We have our Y position, and what we are going to do in here is actually change the order in which the tiles are generated. So we start with 10 for Y and go down to 1 in -1 steps. So let's render again and see if it works. And as you can see now, we are actually having like the appropriate result we want to have. Okay, that's it for now. I did a few more adjustments into our code. I actually enabled the full screen mode. I added a tilemap update function that maps basically the offset we did before in the setup to the tiles when the update is called. Update is called before draw. And I also added to the assets manager a collection type, which basically allows us to add a collection of images and just pick randomly one of them. I added a few more renders. I added a few trees and the grass tile. And for the tile render function, I added to first render the grass tile and then one randomly picked tree asset on tile creation. So let's hop into the map one last time. And as you can see now, our little tile map actually looks like a little tile map now. you have like a random tree selection, you have like the grass floor. So yeah, that's it for now. Next time we're going to look into how to actually put animations on the tile map. Thanks for watching.